Let us now solve a couple of intensive problems related to the first law of thermodynamics. Say we have a graph. This graph is a rho versus P graph, which is between the density of the gas and the pressure of the gas at the point. Say we have a process which goes from A to B along a line which passes through the origin. This is B, this is A. This comes down to C along a constant pressure path which is vertical, and this completes the cycle by going back to A. So this is our process, or this is our cycle rather. This coordinate on the x-axis is 2p0. This is p0. This is rho naught. And this here is 2 rho naught. It is said that there is 1 mole of gas. The gas is monoatomic. The molar mass of the gas is m. We need to find out W for each process. We also need to find out heat rejected by the gas for the cycle. And we need to find out the efficiency of the cycle. These are some things we need to find out. Let us go about doing this problem. As per the data which is given, you can find out, because it is 1 mole, which is n equal to 1, this implies that the mass of the gas we are dealing with is nothing but the molar mass. We also know that density of a gas can be represented by this formula, as we discussed in the gas processes part and heat transfer part. This is given by this formula. Also, we know that density is mass by volume. In our case, this mass is going to be nothing but the molar mass by volume. So volume becomes equal to the mass times the mass divided by the density. So this is something we already know. Let us look at the process AB. If we want to figure out different parameters for the process AB, we need to find out the state of the gas at A and state of the gas at B. So at A, the pressure of the gas is P0. Volume of the gas is nothing but m by the density, which is nothing but rho naught. The temperature of the gas can be found out from the equation of state. This you can easily determine to be P0 m by R rho naught. As the number of moles of the gas is 1. So this is the state at A. At B, the state of the gas for the pressure is 2p0. The volume, if you need to figure this out, this is going to be nothing but m by 2 rho naught. Temperature from the equation of state becomes 2p0 times m by R times 2 rho naught. So the temperature remains the same. This is P0 m by R. So from this data you can say that temperature is constant, hence AB is an isothermal process. Because AB is an isothermal process, you can say that the internal energy change, that is delta UAB, this is going to be equal to 0. Because we have this, we can directly state that Q is equal to W. Our job now is to find out what is W. Let us find that out. For an isothermal process, W is given by nRT ln Vf by Pi. This is what we derived earlier. N in our case is 1, R remains the same. Temperature here is nothing but P naught M R by P naught M by R rho naught. So the temperature is P naught M by R rho naught. This gets multiplied with the ln of final volume by initial volume. Our final volume was M by 2 rho naught. Our initial volume was M by rho naught. So M by 2 rho naught divided by M by rho naught. This will give us minus P naught M by rho naught ln 2. This comes up. This turns out to be ln of 1 by 2, which gives you the negative sign. So this is the work done from A to B, and thus this is also equal to the heat transfer to the gas, so from the gas in the process AB. So this work which is done, this is done on the gas and not by the gas. So we have found out a little part of our question, which is WAB. We found this out to be minus P naught M by rho naught into ln. This solves one part of the first part. Now let us look at the next process, which is the process B to C. The state C of the gas is unknown because they already determined the state B. At state C, the pressure is going to be 2 P naught. The volume is going to be M by rho naught. The temperature of the gas, this is going to be 2 P naught times M by R rho naught. So this is the state of the gas at C. The process B to C, as we can say, C is clearly going to be an isobaric process because the pressure remains the same from B to C. For an isobaric process, if we try to determine what W is going to be nothing but P delta V. This is going to be the pressure times the change in volume. The final volume is M by rho naught. The initial volume was M by 2 rho naught. So this is going to be 2 P naught M by 2 rho naught, which is nothing but P naught M by rho naught. This is WBC. So we have found out another part of the first part. WBC is going to be equal to P naught M by rho naught. QBC is going to be equal to WBC plus delta UBC, or we can directly write for an isobaric process, this is going to be Cp delta T. Cp is going to be R gamma by gamma minus 1. For a monoatomic gas, the gamma is going to be 4 by 3. Sorry, the gamma is going to be 5 by 3. From that, we can write R times 5 by 3 divided by 5 by 3 minus 1, which is nothing but 3 by 2. This is going to be 5 by 3. This is divided by 5 by 3 minus 1. this multiplied with the change in temperature. The temperature now is 2 P naught M by R rho naught. The initial temperature was P naught M by R rho naught. So clearly you can see that there is a decrease in the temperature. Sorry, there is an increase in the temperature. As the temperature is getting increased, the net change in the temperature is P naught M by R rho naught. This quantity is going to be nothing but 5 by 2 P naught M by rho naught.